Hello friend and welcome to HaXeZ, where today I want to talk about tools, and one tool in particular is Nmap. Nmap is an extremely powerful network scanner, network mapping tool created by Gordon Lyon. I'm not sure if I got his surname correctly. It can be used to discover hosts on the network, and it does this by sending packets to those hosts and then analyzing the responses. It helps it understand the services. In other words, if you are able to get onto a network and you need to discover what hosts are also on that network, you can use Nmap to scan it. So, imagine you've plugged into an Ethernet port somewhere on a building. You're on the red team engagement, you've plugged in your Ethernet cable, and you've been given an IP address assigned via the DHCP server. You can check your IP address by typing in ifconfig, and you can see there that I am 192.168.56.102. But now you want to see what other hosts are available on the network. Now, we know that our subnet mask is 255.255.255.0. This tells us that we're on a Class C subnet and that the first 3 octets of the IP address are being used for the network. So the network address is 192.168.56.0. So we can ping sweep that network from .0 to the end, which is 255, and that should be able to tell us what hosts are online. And we can do this simply by going sudo nmap-sp. As you can see, I've typed that out earlier. Now you can do this in one of 2 ways. So you can go from 0 to 255, or you can just substitute it with the seeder address, which is 24. And once you run that, Nmap will send out ICMP ping packets to the hosts and see which ones respond. As you can see, I'm running it there, and we can see that a number of hosts have responded. As expected, .1, which is probably the default gateway, has responded. .100, .103, .102, and of course that's going to include my address 102 because we are pinging the entire network. Unfortunately, this type of network mapping isn't foolproof because some hosts may have ICMP disabled on their firewall, so you're going to have to be a lot more tactical about how you approach those. You can use arguments like -pn to do a network scan and it won't ping it. You can also turn off DNS resolution by typing -n, which will mean it doesn't do DNS resolution, which could improve the clarity of your scans. So now that we know which hosts are on the network, we can do what's called a TCP scan to enumerate what services are listening on a particular host. Now you can feed it a list of IP addresses, or you could do the entire range, but for the purposes of this, we're just going to do one host, and we're going to look at that 103. So to start off with, you're going to do a sudo nmap-s capital T for TCP, and then you're going to pop the IP address in, 68.56.103. Now, by default, Nmap will scan, I believe it's the top 1,000 or the top 100 ports without you specifying any more. But what you can do is you can add arguments like -p, which will tell it which port to do. I believe you can do P0, which will tell it how many ports. You can specify a single port like 25 for SMTP. Might need a space there, so you could do like 25, 30. I believe that's how it works. It's been a long time since I've done it, and I tend to just do all ports. So what I tend to do is I just throw in the P0 argument there. Don't think you need the 0, but you can do it this way. So I'm telling it to do an Nmap's TCP scan of all ports against that 192.168.56.103. Now, a TCP scan utilizes a 3-way handshake. So what it does is it will send the 3-way handshake sequence to the host, and it will listen to the response from the host to determine what service it is. So a TCP scan, it will send a SYN packet, which will tell it to synchronize. Then the recipient host will send a SYN and an acknowledgement packet back to your machine, and then you will send an acknowledgement packet back to the target. Now, as you can see there, we've done a TCP scan of that address, and we can see there's a lot of ports that are open. So you've got FTP, SSH, Telnet. for those who don't know, what I'm doing is I'm scanning a virtual machine in my network running Metasploitable. It's a box that's intentionally vulnerable to the Metasploit tool, so it's got loads of services open and loads of vulnerabilities with that service. So what we can also do as well to improve the sort of verbosity of the scan is we can add additional arguments on there. So we're doing st, sp. What we can also do is we can do sv, and that will tell us the version of the services. It will perform what's known as a banner grab. So it will attempt to connect to each service and see what message is displayed when connecting to it. There is a script that you can do manually, which is --script equals banner or --script banner. And what that does is it essentially connects to the port, waits for the message from the service to see what version it's using. What you can also do is do -o, and that will do operating system detection. So if you look at the results now, okay, it's telling us a bit about the services, but not that much. We've got FTP, SSH, Telnet. But if we add the SV flag on, we get a lot more information back once the scan completes. So as you can see, now that the results have come back, we have a lot more information. So not only do we know the port, the state and the service, we also know the version of the service that's running, which is really useful if you want to identify vulnerabilities in that particular service. I believe VSFTP, or one of these FTP services, pretty sure it's the first one, has a backdoor in it whereby if you send it a smiley face for the login, it will actually log you in. It's just something that was coded into the particular release and was discovered later on and listed as a CVE. So having service information is really useful when trying to identify vulnerabilities in those particular services. So we now know how to do a TCP scan, but there's also another protocol which will have services on there. There's two primary protocols, TCP and UDP. Now UDP is a stateless protocol, meaning you don't have to wait for a response in order to send the next packet. It's used for communications that involve things like video, where it's more about receiving the data rather than the actual specific quality of the data. I always do a terrible job of explaining it, but essentially you don't need a three-way handshake to do a UDP transmission, which does make it more difficult to identify services listening on UDP. It takes a lot longer to do it. So I'm not even sure if Metasploitable has any UDP packets, but services. But what I'm going to do is I'm just going to come back here. I'm just going to do SU. So all I need to do is sudo nmap SU for UDP and then the IP address. I'm not going to do all ports because that will take forever. And I'm not going to try to enumerate the versions. As you've seen with the TCP one, you can do that with just SV. But if we run that and wait for it to complete. So as you can see, our UDP has finally completed. I believe it took about 10 minutes and I wasn't even requesting that much information. So it does take an awfully long time. Something you want to sort of set off and leave running in the background and then just output to a file. You can see here we do have services like 53, which is DNS, and a bunch of other unknowns which are either filtered or being blocked by the firewall. You've got NFS there, which is for network file sharing. It's a bit like SMB. But yeah, that is your UDP scan. It's recommended that you do one on all the hosts that you check, just to have a complete picture of the services that the hosts are listening to. God forbid something happens during your engagement and you need to show your tool output to show exactly what you've done at what times. It's always good to take a note of everything you've done, including the UDP scan, because that's probably one of the prerequisites. So just include it in your scans, have it run in the background and save it to a file just in case. Now, one of the most powerful things about Nmap is its scripting engine. And if you're new to computing or cyber in general, you can be forgiven for not knowing that it has this scripting engine. It's extremely powerful and there are a lot of different scripts in there, whether it's from reconnaissance to exploitation, that you can use in your hacking exploits or your penetration tests. In order to see just the sheer amount of scripts, you can run a scan. You can run a query where you just run locate and then you use a wildcard and you type NSE and hit return. And you can see here just the sheer amount of scripts that it's returned. There's just an absolute wealth. You've got vulnerabilities for various HTTP services, trace routes, stored XSS, slow Norris. That's an attack whereby you send it's specifically crafted requests to an Apache server where you max out all the connections and it causes a denial of service attack. I believe that's what the hacker known as Jester was using to take down a bunch of terrorism related websites way back when. But you can see here there's just an absolute amount of scripts, FTP brute force, that you can use in addition with in conjunction with Nmap to facilitate more information gathering or to even exploit the host. One thing you will need to do occasionally as well is to update the database of scripts, and that can just be done by doing sudo nmap -script -update db, and once you run that, it will look for the latest scripts and download them for you. Now, one thing that pen testers absolutely adore doing, sarcasm intended, is checking the SSL certificates on the hosts that you're scanning. SSL can have a number of weaknesses. Essentially, SSL is the method by which information is encrypted when you're sending it to and from a host. So if you browse a website and you notice it's got that padlock up in the top, it's the SSL certificate and it's encrypting the information, sending it to and from. The reason why it's necessary is because if you are on like a public network or even your own network and you were submitting sensitive information like card details, passwords to a website, somebody else, a malicious threat actor, could be sat on the network and he could be using a tool like Wireshark to intercept all transmissions sent to and from the website or from you, and he would be able to read that information in plain text if it wasn't secured with an SSL certificate and the corresponding protocol. So what penetration testers have to do in a lot of cases is verify that the SSL certificate doesn't have any weaknesses like Heartbleed or isn't using outdated protocols like TLS or even the old SSL versions, which can be easily broken and cracked, so you could intercept that information and crack it. And now there are Nmap tools that allow you to test the SSL certificate. So for instance, we can do sudo nmap -script SSL-cert -p is going to be 443 because that's HTTPS, the encrypted version of HTTP, which runs on port 80. And I'm just going to do my own domain here. Hopefully that will come back with some information. Brilliant. So we can see there that my common name is hax.org. The alternative name, I am using the wildcard. Please forgive me. Again, there are some reports out there which suggest using a wildcard isn't that good, because if you're able to hack a subdomain of the primary domain name or the certificate authority, you can set up malicious services under my domain and it would appear like a legitimate service. You wouldn't get the warnings in your browser. It would use the trust of the hax.org domain in order to serve attacks to other users. So we have that one. We have basic certificate information, but what we can also do is we can also do sudo nmap -script SSL-enum -ciphers, again on port 443, and then we just pop the domain in. And after a while, what we should get is the SSL ciphers that come back. So you can see here that for some reason I do actually have ciphers available on TLS 1.0. I'll have to get onto the server and disable those. The same with TLS 1.1. But we can see also the TLS 1.2 ciphers, what they've got enabled, TLS 1.3. And yeah, essentially you can see what ciphers shouldn't be there and report them back to the product owner and say you should disable these because these are not considered secure, because a threat actor could do what's known as a downgrade attack, where he forces you to use a less secure cipher and he grabs the information and then he's able to crack it. Again, terrible explanation of how it's actually performed, but yeah, there are some really good SSL enumeration scripts here that you can use to complement your other tools like Nessus, just to have as a backup if you need to include them in the report. So another one of the scripts that is insanely powerful is what's called a zone transfer. So imagine you've landed on a network, you've enumerated some information about some hosts and you know what their domain is, but you also notice that TCP port 53 is open, and it needs to be TCP because TCP indicates that the server is accepting what's called a zone transfer. And a DNS zone transfer is essentially that all DNS records are stored in what's called a zone file, and a zone transfer means you can grab that information as though you were transferring it to a different server. In order to perform a zone transfer, we're going to use a external domain name which is set up for the purposes of performing zone transfers. It's DigiNinja and the domain is zonetransfer.me. So if we do sudo nmap -script DNS -, see that I've already done it, so I will tab complete it, but it's DNS-zone-transfer.nse. That's the script, and then you add script args for script arguments, and you tell them that the DNS zone transfer domain is zonetransfer.me and the port is 53 on the host name server ZTM1, NSZTM1, I assume that stands for name server, digi.ninja. And once you hit return, what should happen is it will send a request to that server asking it to perform a DNS zone transfer. And you can see here all the sensitive information that you can gather from it. So in here you could find their email servers, you could find keys for their domains, stuff hidden in text records. Again, it can provide a wealth of information, especially if you're on an internal network. It could tell you where other hosts are, what the IP addresses of those hosts are, where they resolve to. So again, you can see here someone's actually tried to perform a cross-site scripting attack in the TXT record there. That's pretty funny. But yeah, and you've got another one there, hi Josh to all his class. People have sort of been messing with this and adding their own records, but it's a good example to try it on. It's perfectly legal. They say you can do it. So that is a zone transfer, and again, it can provide a huge amount of information, and it's one definitely to add to your arsenal. That isn't to say there aren't better tools out there with much simplified syntax. For instance, Dig, I believe you can do a zone transfer with just the argument -axfr. And there's also Fierce, which is another good one. I'll be sure to do follow-up videos on all those at some point. But yeah, if you're in a pinch and you've only got Nmap available, say for instance you've gone into a network, you've got a box and the only tool available on that box is Nmap, then that's how you perform a zone transfer with Nmap. Continuing on, imagine that you've landed inside a network and you've found some Windows machines, potentially a domain controller, and you notice that ports 139 and 445 are open. This suggests that SMB, or server message block, is listening or is serving files onto the network. And what you can do in some circumstances is you can enumerate those shares and find out what's being shared to the network. There's a script for this, so if we do sudo nmap, you can see that I've just run it. And if we run that, what this will do is it will probe the SMB service and attempt to enumerate what shares are available. And you can see there we've got a share called admin, max users unlimited. We've got a share called IPC, which I believe is a default share on Windows systems. We have OPT. We have a printer share. This is, again, it's running on a Linux box, but it's doing a very good job of emulating what you would find in a normal sort of Windows network, possibly on a domain controller or just a Windows box that's sharing information. But what we can do even more is if we do sudo nmap --script smb -enum -users.nse, again on port 445 and then 192.168.56.103, what this will do is it will attempt to enumerate the users that are available, or what users can access those shares, or what users are in fact on the system. So you can see there, it is metasploitable, but it goes through and it checks the users. So you can see there you've got a backup user with an RID of 1068, you've got a bin user, you've got bind user. So these are going to be like users for services. So bind's going to be the DNS, DHCP user, FTP users. So this can provide a wealth of information, and what you can do is, now that you know these users exist, you can put them into a word list file. So you would just filter this data out using sed, awk even, print out the users and pipe them into a file so that you have users accounts. Again, you've got root there, proftpd, and then what you can do is you can take the information that you've gathered from these phases or from these enumeration scripts and use them to brute force services. So as just mentioned, once you've gathered a lot of information, such as usernames and potential passwords, you can pop them into word lists, and using Nmap you can perform brute force attacks against services on target hosts. Just to help us out a bit more, what you can do on Kali as well is Kali does have built-in word lists. So you could do locate word list and then grep for password, and as you can see there, you've got a bunch of passwords. You could also do the same for user. Sorry, bear with me. And all I've done is I've just taken a couple, I've taken a usernames list and a passwords list, and I've copied them into my current directory just to make the next part easier for me to do. So, for instance, we know from our Nmap scans earlier that the host ending 103 was running an FTP service. So what we can do is we can brute force that service by using the Nmap FTP brute script. So if we do --script FTP -brute, and then we want to specify -p21, and then we want to tell it the host 2.168.56.103, and then we want to add some arguments to the script. So we want to tell it that the user db equals a file that I've created called users.txt, and then we want to put a comma in there and do password db equals password.txt. I think that's it. Sorry, it's been a while since I've done this. So yeah, you can do sudo script ftp brute, specify the port, specify the host, give it some arguments telling it where the user file is and your password file is, and then hit return. Fingers crossed. Do you know what I forgot to do? I forgot to tell it that we're using Nmap. Rookie mistake. So after a bit of time, you will get some information pop back up on screen, and you can see that it's found some valid users. So we've got FTP and user. So what we could try and do with that is FTP to the host and see if they actually work. And there we go, we have logged in successfully. And yeah, it's listing out the contents of the directory, which are currently empty. But that is how you would do an FTP brute force against the service using Nmap. And what we can also do is, we know that the host was using SSH. It had SSH service listening as well. So we can do exactly the same thing, but with the SSH script. So we'd have to, I'm going to tell it to use T4 to make it faster with no DNS resolution, but I'm going to do script equals SSH hyphen brute hyphen script hyphen args user db equals, I think I put it as SSH user.txt, and then we can do pass db equals SSH pass.txt, I think I called it, and then we're going to tell it to do port 22, not 33, and then we're going to give it the host name, and then hit return. And as you can see there, it's trying a bunch of different usernames and passwords until it will find a correct pair and tell us what the correct one is. I feel like I prefer this visual layout on this one, mainly because it's actually telling you the attempts it's doing. I'm sure there's probably a way to do that with the FTP brute, but as far as I was aware, I couldn't see a way to do that. Now that the attack has finished, you can see that it's found a valid set of credentials called user. So we can just try user at 192.168.56.103, I think it was, and then that should prompt us unable to negotiate, no matching host key found. Okay, so it looks as though there was an issue with the keys due to the version of OpenSSH, but one quick Google search for this error message here led me to the Ubuntu forums, which told me to add this argument here, which then allows you to connect to the box and log in as user. So we were able to successfully brute force the FTP and SSH services using built-in word lists. Granted, the usernames and passwords were fairly simple, but that got us into the host, and once you're in the host you can then do things like privilege escalation to get from user to root, or in order to escalate your privileges and take full control of the system, exfiltrate data off of it, or submit it in your report and say we were able to own the system by doing this brute force attack because you were using easily guessable credentials. But that's it, that's how you would perform an FTP brute force attack and an SSH brute force attack. So there's a few more arguments and a few more flags that I want to add in before wrapping up, mainly because I found them useful. The first of which is the -t flag, and you can give it a numerical value of 1 to 4. And what this does is it sort of affects the speed of the scan. So if you did a -t4, you should see that the information comes back relatively quickly. That's because you're telling it to do it as fast as possible. But you have to be careful with this flag. The reason why is because if you're doing a quite intensive scan, getting service versions, running a few scripts to enumerate vulnerabilities, and it's absolutely hammering the machine, it could affect the performance of that machine and exhaust its resources. That would of course affect the availability from that CIA model of security, which could land you in a bit of trouble if you knock the box offline. Another flag I want to talk about is the verbosity flag. So if, for instance, we go back to our scans and we want to do an SV with OS recognition, and we want to do all ports, but we want to see what the script is doing when we're doing it, what we can do is we can do a lowercase v and add a numerical 4, 1 to 4, and this will affect the level of verbosity that's output to the screen. So if we hit return now, you can see there, instead of just waiting to tell us what ports are open, it goes through and it tells us as it's doing it what services it's found. And finally, I want to talk about saving formats. Now, there are a number of different options that you can use. For example, if I was to bring up the scan I've just run and I want to do -on and save it as one scan.txt, that's going to output the results to a file. As you can see there, initiated the scan. I hasn't really put much in there, but what we can also do though is we can save it as an XML file by giving it the OX and then saying scan.xml, which can be useful if you want to pass the data into other tools. And again, that works, and we can just do cat scan.xml. There you go, you can see that it's got all your XML tags in there. And we can also do a greppable format. So we just change that to OG and do the same again. So we can just call this one scan.grep. Control C that, and then cat scan.grep. See there, it's got some information in there. But one useful format is if we do the scan again, we can save it as OA or. And what that will do is that will create a directory, I believe, or a folder, or just a number of, you can see there it says or.gmap, or.xml, or.mmap. So it creates all files instead of just the individual ones that you specify. One thing that I like to do with all of my tool output, and it's based on exams, because when you do exams, you need to save every sort of scan you do so you can show it to the examiner and be like, this is the results of this that you told me to do, this is the results of that you told me to do. And I'm not going to argue that the outputs of the individual saves, whether it's a text file, an XML file, a greppable file, are better. But one thing I like to do with all my scans is I like to pipe T-A and then give it a name. And then that will run, and what it does is that just pipes everything to a text file, and you can see there it has everything in there that we wanted to save. And the reason why I like doing that is because it works with every program. It's a native Linux terminal argument, and you can just put any output you want into there. Sometimes the formatting can mess up with tools like TesterCell and SQRmap, but it's just a handy little trick that I picked up a while ago, which I use for pretty much everything. I append it onto every command just so that I have a copy of the tool output saved. So in conclusion, Nmap again is such a powerful tool, and I was ignorant to its powerfulness when I was in tech support before I got into cybersecurity. I used it to discover open ports and stuff like that in my job, but I didn't realize just how much functionality the tool had, how many individual scripts it had built in, which are included when you install it. I mean, I could sit here and talk about SYN scans, Xmas scans, and spend weeks talking about all the different scripts that are available, but that would take me forever. I mean, there's just so much depth to it, and all the different services that you can exploit with it. It's just an amazing tool, and is an essential tool for your hacking or penetration testing toolkit. You know, I could go into an engagement and probably get away with just Nmap. I could probably do most things, obviously with built-in tools like FTP, Reminif, RDP, and other tools like that. But for identifying weaknesses and vulnerabilities, I could probably do my job with just Nmap at the moment. I mean, as I learn more, I will probably come to regret saying that. But if I'm on a network and I'm scanning it, I do feel like Nmap has enough there for me to get on with, and for a vulnerability scan at least, to identify all the weaknesses. It's a great tool, and yeah, I wish I could go into more depth, but this video is always getting on a bit. I'm sure I've missed out a bunch of stuff that you use and you love, but yeah, this is what I feel are some useful insights into Nmap, and yeah, I hope you liked the video. If you did, please give me a thumbs up, leave a comment, and maybe you could subscribe, and I will see you next time. Kind regards.